Hi, everyone, and welcome to our November virtual session in the DevSecOps community. We're excited to have you with us. I'll give it a couple minutes for folks to join and to get settled. We have a few updates from the community. I'll give you those in a couple minutes. So just for just so you understand what's going on today, we're going to have a brief update about the community. We will have an excellent session with Stefan on the future of DevSecOps, and then we will have Q&A. If you are not familiar with our sessions, now's the time to get acquainted. You can head over to the DevSecOps community, devsecon.com/events/the future of DevSecOps with hyphens. And you'll be able to see the event live in the community, or you can see it streamed live to our YouTube. At the top of the page inside the DevSecOps website, you'll find a join our Slack link. If you have not yet joined our Slack, you are welcome to do so. Stefan is live in the chat as well, and you can ask him questions throughout the event. And I will be here monitoring both the Slack and the YouTube, so definitely feel free to ask questions. And get the most out of the session. So just so you know what's going on in the DevSecOps community, this is our November event, and we already have our December event lined up as well. That'll be on Open Policy Agent with Ronen Levinson. That'll be December 8th, so definitely register for that. That'll be a good session as well. We have coming up in December, every single day in December, we will be publishing an excellent security blog post, what we will be calling the SecAdvent blog post series, an homage to the SysAdvent blog post series of yore. So 25 excellent security blog posts. Stay tuned for those. Follow our blog. Click on content and go to blog. Also coming up, the DevSecOps Leadership Awards. Every year we like to honor the most brilliant minds in the DevSecOps sphere. So now is the time to nominate those that you deem most worthy. You can find that also on the blog. So find the blog post announcing the DevSecOps Leadership Awards, and you can see the guidelines for nominating. You can nominate yourself, you can nominate your team, the community that you're involved in, so definitely do that. We want the most deserving DevSecOps individuals to win the award, and we will be announcing them in a wonderful ceremony at the end of January. Nominations close at the end of December 31st, so definitely get your vote in. That's the DevSecOps Leadership Award. Today, we're dropping an excellent ebook on the homepage, Docker and SNCC ebook on container security, so you'll want to check that out. And definitely more goodies to come in the community, so follow us on Twitter, DevSecOps, join our Slack, and we'll be sure to keep you updated on everything that's happening in the DevSecOps sphere. So without further ado, I'm going to add our today's speaker. So welcome, Stefan.
Hi, Sharon. Thanks.
Excited to have you here. Aside from working at Guardrails and being, having years of experience in the DevSecOps sphere, Stefan also leads the one of the biggest DevSecOps meetups in APAC. So you can definitely follow him on Twitter as well. And I remember that his username is a little bit complicated. Help me out with your Twitter username. It's S_, right?
Streichsbier, but it's my last name, so don't worry. You're gonna break your tongue.
So I really did want to read your bio here, but I see I have a glitch on my website where it's like the wrong font color. So I'm gonna have to fix that. But trust me when I say he has years of mileage, and you'll definitely want to hear this excellent talk by Stefan on the future of DevSecOps, so we all know what's coming. So I'll let you take it from here. And don't forget to ask your questions in the chat. So I am monitoring the chat, and take it away.
All right, thanks a lot, Sharon. And hi, everybody that's tuning in live this afternoon. I'm in Bangkok, so my time zone is quite different, and it's midnight here. So yeah, we're gonna talk about the future of DevSecOps tonight. And This is a talk that's quite dear to me, so I hope you enjoyed as well. I'm looking forward to any questions that you have. So a little bit about me, in addition to what Sharon has said before, is I have been previously a white hat hacker for pretty much most of my career. And it's been quite interesting because you kind of see a lot of things along the way. But I think one of the most significant events that I had in my career was really being part of the DevOps days in Singapore back in 2015. Because for the first time, I realized how far behind security people are in their mindset in embracing security in the modern age of agile and DevOps. And as a result of attending this meetup, like this conference actually, I created a DevSecOps community and have been very active in building it up in Southeast Asia and around the world. I've actually DevSecCon, I was there with Francois, creating it in Singapore for the first time a while ago now. So I've been doing a lot, talking, organizing, even brought out a book called Epic Failures in DevSecOps. So if you want to get this book, I have a link for you later as well. But anyways, along these all of the time I spent on DevSecOps, I've worked with a lot of organizations in Asia and around the world where I really realized that there's a lot of problems with the way security is being embedded and the technologies that existed, which also led me to create the company Guardrails.io. So if you haven't checked that out as well, go to the URL or catch me later on Slack if you want to check it out. I think you would enjoy it quite a bit. Anyways, now we're gonna continue, and we're gonna actually, oh, there's a bit of an issue here. So we're gonna talk about the future of DevSecOps, but in order to do this, we're gonna also talk about first the past, like what has happened so far, the present, where we are today, and what the challenges are that we are facing, and also the future, which we'll take a look at the crystal ball to see where things are at. So let's kick it off with a quote. To understand the future, we have to understand the past. So in order to do that, we're gonna tune in, like we're gonna zoom out a little bit in in the history, and we're gonna talk about industrial revolutions. And many of you may have heard about this before, but actually we have already experienced 3 of these industrial revolutions already, and we are on the verge of the 4th one. So the first one was actually a really big one that moved humanity from hand production to machines, leveraging steam and water power, and really was responsible for leading people into the cities, right? So most of the population has actually been across agriculture before, and because of this first industrial revolution, people were streaming into the cities, and cities were starting to rise. The second one is actually when mass production and assembly lines were introduced, which led to, for example, Ford, they had like the assembly line, and they used it to actually reduce the time it takes to build a car from over 12 hours to just 33 minutes. And there also was the usage of electrical grid systems and telephones, which obviously changed the way that we communicate. And unfortunately, all of these new developments played a major role in World War I. Then we had the third industrial revolution, which where MOS transistors replaced the vacuum tubes and revolutionized the way that modern computers work, which led to a lot more development. So actually in 1985, obviously in 1985, waterfall was being introduced for the first time, which we all know. And we also had the invention of the internet in 89. And by the end of that decade, 15% of the American households had personal computers in the US, right? So there's the second part to this industrial revolution, which is the second decade, 1990s. And well, actually 1990s until 2020. And so we had actually the first web browser back then that came out, Mosaic, that was able to support pictures. We had the first ever online banking application that came out in 94. And by the way, to those that are listening, if you actually happen to know what language this online banking application was written in, do let me know, because I would love to find out. I couldn't actually research that. Anyways, in 2001, the Agile Manifesto was created. In 2009, the first DevOps Days was being hosted. And today, over 60% of the world have actually access to the internet. So, and this is where we are today. And from pretty much next year onwards, I think we will have the fourth industrial revolution. And this will start merging the physical, digital, and biological worlds. For example, you may have heard about Neuralink together into one, which is going to be quite exciting. Also, quantum supremacy has been achieved last year, and quantum computers will start powering this next revolution. Also, robotics will become more widespread, and of course, artificial intelligence will influence every aspect of our lives, which is also going to be a key element for the future of DevSecOps and security as a whole, which we're going to explore later. Now, so another another slide on the history at the past so far is going to look at security and software and opposes it a little bit. Because the main point that we're going to bring out here is that security so far has always been lagging behind of what software has been accomplishing. So if you look at this in the 1990s, actually a little bit before that, waterfall was introduced by the Department of Defense. We got public access to the internet. Personal computers became a thing, and the programming languages that were created in this era were Java, Python, Ruby, and JavaScript. A decade later, the 2000s, we had the Agile Manifesto, cloud computing. We had smartphones, which obviously was a big impact. And the programming languages of this era were C#, Scala, PowerShell, and Go. And in this current decade, DevOps actually was introduced. Well, it was late 2009. And the rise of containers and smart everything, Internet of Things was being introduced as well. And the languages to go with that was Rust, Kotlin, Elixir, and Swift. However, if you look at the security industry, in 1991, it was all about antiviruses. So this was when the first antivirus was being made public. We had the first kind of high-profile hack worth $10 million affecting Citibank. We had Kevin Mitnick, which was an infamous hacker back then on the FBI most wanted list that got arrested. There's also a really good movie if you want to check it out about that. There were some really influential papers being produced, like Smashing the Stack for Fun and Profit, which was at least very influential for my own hacking career back then. And by the end of this decade, there were hundreds of advisories for Windows machines. The following decade, we had the first computer worm that started having widespread impacts, abusing these systems that were missing patches. But we also started having the first static analysis tools. And also in 2004, Microsoft back then internally has created the Microsoft Secure Development Lifecycle, which was only released in 2006 actually, which was also the year where BSIM, the Building Security in Maturity model, was publicized. And we also had a configure worm. So this was still the decade of worms and everything. And but yeah, quite interesting and changing quite a bit and moving away from just antiviruses in the previous decade. And now in this current decade that we are in, we had very sophisticated attacks such as Operation Aurora, Stuxnet, etc. But more and more it started going into these data breaches, which we had Tumblr in the 2013. In 2016, we had a big attack against some Bangladeshi bank. And nowadays, since 2017 onwards, there have been data breaches left, right, and center. And the point I want to bring out here is that in the 1990s, the focus on security was really mainly on the operating systems. In the 2000s, it was focusing more and more on the network services. And since the 2010s, it's really focusing on applications. And I want to point out that it's really important to realize the delay between what happened in the software world and how long it took security to catch up. So if you look at Waterfall, the first official development approach or life cycle or process, if you will, has been released in 1985. However, the first static analysis tool was only created in 2003, which is almost 20 years later. And the Microsoft SDL, again, 20 years later, was only coming out. So there's 2 decades between, formalizing how software development should happen until we actually had security catching up, creating tools to identify how software is being secured. Anyways, so now we're going to go back for a moment and talk about the present. And we're going to talk about the present with a quote from Buddha. Do not dwell in the past, do not dream of the future, concentrate the mind on the present moment. And my slides got messed up, so apologies here. We're going to dive now into the next slide. So if you look at software engineering and the present state, a lot has actually happened in the past, and software development as a discipline has evolved, and very much by leveraging the principles of lean manufacturing and iterative and incremental software processes. So actually what Henry Ford did back then in the second industrial revolution, the same principles are being applied to software development, which led to Agile and DevOps being revolutionizing the way software is being developed. So if you compare just what we had in the past to where we are now, it's actually quite obvious. So back then we had slow release cycles. We talk about quarters, maybe years, whereas today companies release very often, probably a few times a day for those that are high-performing DevOps practitioners. It used to be focused on manual deployments, whereas today it's completely automated. You have your continuous integration, continuous deployment pipelines, and every time something is committed and pushed, it's just going to be automatically tested and, if possible, deployed. Back then, we only actually version controlled code, but nowadays everything is actually version controlled. So, for example, infrastructure as code is a really good example of how you actually completely have software-defined networks. Everything is as code, and you store it in your version control system. Also back then, especially when I started in security, there was a very strict separation of teams, and actually we had like separate development teams, operation teams, and security teams, whereas nowadays they're cross-functional. Nowadays you actually want to have team members that know about development, operations, and security, because you have to know a little bit of everything and obviously focus on one area to be really helping out and focusing on supporting your team and your organization. Also, we had monolithic architectures versus nowadays microservices, where it's much smaller components that are easier to test, deploy, and iterate on. And obviously back then, there was very little visibility you have. You have some log files, but now with APM solutions, etc., you have full stack visibility from the front end to the back end and everything in between. Now, if you look at the security engineering side of things, also quite a bit has changed actually. And we're going to look at these changes as well. So on the one hand, back then, like I mentioned, security was a dedicated department and was typically known as the department of no. Whereas nowadays, we actually, security is becoming a business enabler. Also back then, we were looking at one-off security scans, maybe doing a penetration test once a year, but now we have continuous security scanning. So every change that happens has to be analyzed. Also, the security test was typically done at the end, but now we have upfront security analysis. So it's like the shifting left approach that has been talked about quite a bit for DevOps and DevSecOps alike. Also, back then, there was always like the waiting for the issue reports and security reports, but nowadays, you don't have to wait for a PDF to come in. You proactively actually look for vulnerabilities to make sure you have the right. You identify these things before they become a problem, and don't wait for, before release happens before you address these. Also, and this is very personal to me and very important, it used to be a pen testing mindset, whereas today it's more becoming a security engineering mindset. And that was for me personally a huge shift, moving from pen testing to security engineering, because if you're a penetration tester and you write up this beautiful 50, 100-page report with all the things that should be done right, and you would give it to yourself as a security engineer, you would immediately, remove half of the things in there because nobody got time for that. So you have to actually take a very different approach to understanding how security can actually enable your business and what trade-offs you can make to make sure that you can still deliver on time while not compromising on security too much. But these are two very, very different mindsets. All right, so let's talk about the present state challenges. First of all, we have a lot of different security testing techniques. So nowadays we're talking about static analysis, software composition analysis, container security, dynamic scanning, interactive application security scanning, RASP, VA, clouds, whatever. There's so many different things, right? And I think it's very difficult for organizations to even understand what these tools do differently, how they augment each other, and how to actually use them. And on top of that, most security vendors out there don't provide one solution that does everything. So there's a lot of fragmentation actually ongoing, which means if you want to get a good coverage, you have to get solution A, B, C, D, E, and then somehow find a way to actually tie them together, maybe into your own dashboard, to actually see what's going on across all aspects that are relevant. In addition, security tools were traditionally designed for security engineers. And what that means is they aim to provide a lot of results, anything that could possibly be an issue, which results in a lot of noise. If these results are now suddenly prepared for developers and embedded into your, like these tools produce the noise and they're part of your pipelines. And I think this is one of the main issues, because if you have a lot of noise in there, then nobody's going to look at anything. Next up, the integration. So many of the existing tools have been designed to work standalone, maybe as a CLI tool or whatever, but they don't integrate well into the development workflows. So even dropping a tool into a CI/CD pipeline may take a lot of effort, to just maintain it, especially if there's a bunch of different tools out there, and then roll it out not just for one application, but for your whole organization. And this is something that is still a big problem, and organizations typically need a small army of people to really roll out the security tools that they have bought. Another thing is a lot of the tools that are especially doing static analysis or dynamic testing, they take a long time. And then if it takes a long time, you can't implement it in your pipeline, because if developers run a scan every time to commit a new change to your repository, and it takes longer than a couple of minutes, the tool is going to get out of this workflow immediately. And because of that, even in 2020, nightly scans are still a thing, which is, not what was expected. But I think the main problem in the present state is define versus fix. So even like when you start embracing security tools and you start rolling them out and you run it against your own applications, the legacy ones that you may have, you get a lot of results. And even knowing that you have a lot of issues doesn't actually change the problem, right? Because you still have to go and fix all of them. All right, so let's talk about some present state inconvenient truths as well. So if you look at the existing leading security tools out there, you have to understand that a lot of them have been developed over 15 years ago. And, a lot of intellectual property was created and mindset was created like 15 years ago, which is no longer fit to where we are today. And also a lot of these organizations have grown in a way that once they were successful, they started maybe acquiring other organizations and kind of put these solutions together in a way that makes them tick all the boxes when it comes to sales. But many times the solutions are very integrated in a very not so smooth way, let's put it this way. And it looks like a little bit of patch together, and it doesn't really work well on scale and in a meaningful way. Also for these organizations, imagine you have so much IP out there, but now thanks to the advance of open source software, a lot of tools out there exist that actually start to outperform these existing legacy solutions. And I know a few examples where actually open source softwares have outperformed actually enterprise solutions when it comes to scanning. So it becomes much harder now to justify the price for these enterprise solutions because there's a lot of great open source tools out there. And most importantly, I think that many of the companies have since been focusing on the wrong audience, right? So security consultants and security experts are no longer the people that need to be focused on, but actually it should be the people that are develop the software, and that the things actually focus on developers and give them the right feedback to make these things happen. And now we're gonna end on a positive note for the present state. Is there a ray of hope, maybe? So there's a Twitter thread that you may find quite interesting. I'm linking the tweet in the slide as well, and I just have the first tweet here. There's something truly special happening in the static analysis world. Now, this is a world full of dinosaurs, tools that are monolithic and expensive, and really don't work well in pipelines, no matter what the account manager tells you. So check it out. I think you would like it a lot. I'm going to just summarize pretty much what this ray of hope is supposed to be, which is a simple, customizable, and fast static analysis tool for finding security issues. It can run offline and on uncompiled code in your pipelines, or pre-commit, or in your IDE, and it's also company and community backed. So we're talking about tools like CodeQL from GitHub and SameGrab from Return to Corp. And it's actually a very interesting idea because having a tool that allows you to create very smart rules and in a simple way across all languages, it's great. You have something that suddenly starts outperforming and gets all the benefit from the community to identify these issues. And suddenly, obviously this also puts some more pressure on the existing solutions because, yeah, there's actually now these great tools out there that everybody can use. But is it going to be a silver bullet? The answer is unfortunately not, because many concerns are not addressed by just having a static analysis tool. So there's other security testing techniques, like I mentioned earlier. There's also the curation of rules, which is very important, which I'm going to cover a little bit later. And of course, the rollout and orchestration to make sure that you actually get the benefits is still something not addressed by these. So even if you get a perfect static analysis solution, would it solve all your problems? The answer is no, because you still have this big issue of find versus fix. And to illustrate the point, I've taken a screenshot from cvedetails.com, which shows since 1999 until pretty much today, all the different vulnerability categories that we have CVEs for, or like the major ones, and shows every year how many issues were identified for these categories. And shockingly enough, the numbers are not really going down in many areas. In some areas, they're even increasing. And even after like pretty much 20 years of being aware of these vulnerabilities, they should have been eradicated. And I remember when I started my first day as a penetration tester and found a secret injection, I remember that I was already told these things should be extinct, because back then it was already old news. And so today, these issues still persist, and that's why the existing solutions are not really fit for purpose, and there has to be a better way. Which brings us to the last section of this talk, the future. And we're gonna start with a quote. There comes a point where we need to stop just pulling people out of the river. We need to go upstream and find out why they're falling in. And I think the whole talk about security and my whole experience with security to date couldn't be summarized any better. Okay, so what are the goals that need to be achieved? First of all, smart security scanning. Then unifying all security testing techniques. We need native integration, continuous verification, auto-fixing of issues, having security that actually works for developers, and not just developers and Fortune 100 companies, but for everybody. So let's talk about these points in a little bit more detail before we wrap up this session. So let's start with smart security scanning. When we talk about, you probably all have heard about this quote, software is eating the world. And, there's this saying that in the future, or back then was the saying, every company is going to be a technology company that happens to do banking, insurance, whatever, right? But I'm going to go ahead and say, in the future, there will only be data science companies that are going to happen to do X, Y, Z. And this is really important because we're starting to realize that what artificial intelligence and data science can do for us is going to pretty much has the potential to change the way security is being addressed. So we all know that tools that are identifying vulnerabilities based on rules are great and have helped us in many ways. But it's also going to be useful that actually these things will be fed to artificial or deep learning models, that we can actually go away from rules and have something that's actually much smarter. And we can even go as far as to leverage the crowd to mark issues in the code and in other places, because this would mean that things that rules don't identify, but humans can identify, would allow artificial intelligence to learn from this if people would annotate it in the code. Secondly, the findings data set has to be verified, of course, right? So even if tools identify issues, there's always the issue with false positives. And that's where we can also leverage the crowd to verify issues and also help train, the artificial intelligence behind it to be smarter in identifying issues with a high level of accuracy. And that's also why these artificial intelligence solutions have to also understand the code better and understand not just what a rule does in looking at patterns, but actually understand the application, the context of it to make decisions. Next up, all-in-one. So we're already standing on the shoulders of giants. And what we need to do now, we need to find a way to actually add another layer of abstraction, right? So there's so many tools out there. I mean, myself, I've done research. There's hundreds of open source tools, commercial tools, you name it, with do different things for different languages, for different purposes. So there has to be a way to truly and tightly unify all of these solutions into a platform that just tells you what needs to be done across your entire stacks. And that means not just your code or your applications at runtime, but every entire component that make up your production environment. And that means that these solutions also have to be able to cross-reference issues and understand what's the issue in code and how does it correspond with the attack we just seen in runtime, etc. And of course, all of the results have to be stored, in a central place, which then again can be used for the data science purposes that we have discussed previously. Then native integration. I want a term I like the term DevSecOps native, because I think that this is going to be what the future is holding for us, which means that code actually, tools should be able to understand all events that happen on the code runtime infrastructure, like I mentioned. But also, we have to understand how code, for example, is being managed, right? So, I mean, for example, if developers are creating a pull request, the tools have to understand that. If somebody deploys a new version of an application into a staging environment, the tools have to understand that. If you spin up another EC2 instance, the tools have to understand that and react accordingly, so that we don't need actually pipelines to do different things at different times, but the tools can actually understand natively what happens in these different environments and automatically do the right thing to actually identify issues and the changes that are being introduced. And it also has to be very clear about the life cycle of vulnerabilities. So, for example, when has a vulnerability been created? How was it changed in the life cycle? Was it ever fixed? Was it reintroduced? And actually understand how all of this comes together to give really meaningful insights to the people that have to fix these issues and manage these applications. And nowadays, scanning is not enough. We have to talk about continuous verification, right? Which means not just check whether there's issues, there's some fail checks, but also checks that pass, which means you can continuously ensure a known safe state that covers all aspects of security, like we've just talked about in the previous slide. In addition, we also have to make sure that the scanning doesn't just understand what is an issue or not, but also understands how we can actually get compliant with different standards like PCI DSS, HIPAA, etc., etc. And most importantly, when something fails or something is no longer passing, we have to get instant security feedback as well. Next up, auto-fixing. So as I mentioned before, finding issues is not enough. So even if you find, so for example, if you introduce a new vulnerability, a SQL injection, and this actually the tool identifies it and you fix it, it doesn't really matter if you have 10 other SQL injections in your code base, right? Because ultimately, you're not really reducing the risk. So the real labor is actually fixing all issues, ideally one vulnerability class at a time, and then implement controls to prevent these features, these issues to come back in the future. And this is also where auto-fixing will help us at scale, because ideally, we can also find a kind of hybrid approach that leverage data science and maybe gamification to show people what the issue is and help them fix it, and then apply some sort of apply something that allows you to fix all the other occurrences of this kind of issue in your code base. And of course, we also have to focus on leveraging better frameworks that are more opinionated and make it much harder for developers to introduce issues as well. Next up, we also have to acknowledge that developers are key. And that, even though there's a lot of things happening in security, we have to make sure that tools are really fit for developers, which means we also have to standardize security issues, which means what is actually a security issue and why should you care? Because many times the first thing everybody does is when they get the first vulnerabilities report, they blend out the low and medium risk issues and just focus on the high and critical ones. But I've personally looked at so many tools out there, and what's an issue in one tool and not an issue in another is not standardized. And I think that's something that needs to be changed. And also understanding the right risk context of an application, because obviously there's a difference if you have a high value financial application versus a small blog that just has public content on there. And also, most importantly to me, is that it should be so easy to understand and fix issues, and developers don't need a security PhD to understand it, because that's something we security people have been guilty of, to use a lot of acronyms and fancy words for very simple problems. Okay, the last slide before we conclude is a very important one, which is making security accessible to everybody. That's also part of the mission and vision for Guardrails, because right now there's not a lot of security training in schools, and software engineering should take more of a civil engineering approach, which means, when you build a bridge, you don't just say it looks good, looks stable enough, and then things happen. But for software, many times that happens. So it's important that universities and students learn about security the way, like the moment they start learning about software engineering. And another important part is that security is not affordable to everybody at the moment. And there's a lot of open source vulnerabilities, vulnerabilities in open source software that's being used by everybody around the globe, no matter if it's a startup or Fortune 100 company. So it's important that security tools will be made available for these open source projects, so that we can improve the security around the globe for that as well. All right, so to conclude now, when we talk about security practices, a lot they have evolved a lot in the last couple of decades, but clearly not enough. That's why we see a lack of a clear downward trend in vulnerabilities being identified and fixed, and also a rising number of data breaches. Next up, data science will completely change the way security is going to look in the future, which will bring with it a paradigm shift into how security will be applied in practice and what that would mean. But fortunately, I see the future for DevSecOps as a very bright one. So we will see very smart, all-in-one security testing technologies that are highly integrated and tightly integrated into the developer workflow and every system out there. And we provide continuous verification and even auto-fixing. And most importantly, they will not be just available for the few that can afford it, but to everybody out there. And with that, I want to say thank you very much, and want to close the talk with, given that Christmas is around the corner, I have created a virtual goodie bag consisting of Guardrails coupon codes. We have some really cool, awesome security lists, developer trainings, list of great security tools, security page templates, a free digital copy of my book, and many more. So if you want that, just drop me an email to iwant@guardrails.io. I'm going to send a list in return. And now, thank you very much. And Sharon, back over to you.
So, what a great talk. Thank you so much, Stefan. It was really enlightening. Some of it feels like science fiction to me, and I'm going to ask you some questions about that. Before I get to my questions, I will ask you the questions that came in from the community. So actually, there's really only one question, but it's a tough one. So do you think we already have AI architecture suitable for AI-based code analysis and code fixing? Example, maybe something like GPT-3, and that we can adapt to use those, we can adapt those to our use cases? Or do we need still need another technology breakthrough in AI before this becomes feasible?
That's a very good question. And I see it's from Thomas. Hey, Thomas. So actually, I think we have all the tools necessary to make it happen already. And it's obviously not going to be 100% perfect solution right away. But I think with a lot of the advances that we have seen lately, we have all the right tools at our disposal to make that actually work out. There's going to be, of course, a bunch of things to figure out along the way, but I don't think it needs to be like some completely new thing coming along to make it happen. I think we already have everything we need.
It's interesting because that was also going to be my kind of question. I was really going to ask, like, the way that you describe it, that there, the AI or the machine learning, the data science would be so, infrastructure aware and software aware and, all of this aware that it almost seems like science fiction. Today, I mean, we have regular companies having difficulties, defining auto scaling rules,
Right.
So for me, I'm just wondering if you really think that this is feasible in the near future, or what's the term? How long do you think we're far from there?
I think we're going to be 5 to 10 years away from that, to be honest. And maybe it's a little bit optimistic, but I see already some really promising things happening. And even just in the last 2 years, right? Like we've done some internal projects on that as well. And the first project where we applied machine learning to achieve some of the things we wanted to achieve. Funny enough, it took quite a long time to get some results. It was very tricky to use and all of these things. And then we started looking at a different approach, which was actually using deep learning and existing algorithms to make these things happen. And within a week, we actually beat the results of what has taken months already with machine learning. And the best part is it doesn't really need to have a lot of supervised examples to really get good results. So I'm very, very bullish on these things happening, but I think it's going to be obviously a bit of time we need to pass before this is actually going to be super accurate and starting to replace the first tools that are actually rule-based as well.
Okay, that's a good answer. Another thing I want to ask you about, because you spoke mostly about that, about like kind of the futuristic side of DevSecOps and what our processes look like and what technology looks like. But you had a quote at the end that I thought was actually quite poignant about those that are falling into the water, and you have to see why that's happening. Or something. I'm paraphrasing. I'm not very good at quoting.
Right.
But you didn't talk at all about the adversarial side. And one of the first slides, and when you spoke about the revolutions that are coming, you had said that, there's going to be a fusion of digital, physical, biological. Do you think we're at a place to create that level of fusion when there's still so much danger out there? I mean, everything gets compromised so quickly. And to have all of your biological data out there without the proper protections, that to me feels really scary as the next revolution. So are we ready for that revolution from the adversarial side?
Are we ever ready, right? Like what happened with the atomic bomb, right? I mean, this was another thing that's like, okay, are we ready for this or not? Good, bad, completely different story, right? I mean, to me personally, I feel like, I'd rather see us evolving into this way and have technology that can do a lot of great things, right? Obviously, there will always be use cases for this to be abused. And we just take the example of artificial intelligence. You have people that are completely opposing, like saying, you have to supervise it, like Elon Musk or like Ben Ma, like, no, it's going to be fine, whatever, right? So there's a lot of different very smart people having completely different opinions about that. But I think ultimately that's fair, right? Like, no matter what the technology, no matter what cool thing comes out, there's always going to be the way that a possibility that it's going to be abused. And I think, ready or not, it's going to come. And I'm looking forward to it because I'm a big fan of the show Ghost in the Shell and, Matrix and all of these things. So maybe, I hope it's not going to be that dystopian, but,
No, you
some
hope
of
it's not
these
going to be
things
Black
like,
Mirror, you're saying. Have you
sorry?
ever seen Black Mirror? Black Mirror is like the dark
Love
side of
it.
technology.
Yeah.
You hope it's not going to go there, you're saying. You're hoping it's going to go to the more positive sides of
They're
technology.
always dystopian because it sells better, right? But ultimately, I think, yeah, there's a lot of great things. Imagine you can learn kung fu, but just plugging something in, right? So,
Yeah.
anyways, would be cool. Maybe we'll change the game entirely, but I think that's what the previous industrial revolutions have done already, big time. And yeah, it will be exciting to live through another one.
Thank you so much for joining us, Stefan. I see that there are no further questions. Anybody else? Now is the time. I'm checking the Slack. I'm checking the YouTube stream. Any last questions? Oh, I do see that there is a question in the YouTube stream. So what DevSecOps security tool current market, what is the current market missing is the question. What is it definitely missing?
For the DevSecOps tooling.
Mm-hmm.
One solution that combines every single security scanning technique out there in a meaningful way, powered by AI, to actually make sure you have almost zero false positives. But yeah, that's also something we're working on at Guardrails. So stay tuned. Maybe we're getting to this very, very soon. But yeah, we're already working on this as well. But I think this is really what's missing. Yeah.
Okay. And one more question just came in. Currently, we deal with a lot of data breaches. Are there any indicators of what kind of attacks we'll be facing next? It's kind of my question, but it's actually a little bit better, more eloquently stated.
Yeah, a nice question from Peter. Yeah. It's a very good one. I think going down this dystopian path again, you've heard about Neuralink, right? So the next company that Elon Musk has actually started, because apparently he doesn't have enough too many things to do, so he started another company. This is kind of like bridging biology, technology, and yeah, all of these things together, and digital a way of processing things. And I think when this comes around, and this is obviously not around the corner, but it could be conceivable that if people are powered by like cybernetics or other improvements, that like you said, Sharon, this is going to be maybe something that could be attacked. But don't worry, because this is still decades away from being used widely. So for now, I think let's focus on dealing with the data breaches first, and then when something else comes along the way, we can deal with that later.
Okay. I think, oh wait, excellent presentation. Okay, just excellent presentation. Everyone keeps saying that it's an excellent presentation. I'm sure you already understood that. So it's definitely a really great talk, Stefan. Thank you so much for joining us. It's always a pleasure having you in our community. Stefan also contributes content and other things. Definitely stay tuned. He's an active and integral part of our community. Actually, next up on the community circuit, which I forgot to mention, is our next regional DevSecOn event. So join us for Community Summit Tel Aviv. And this is actually probably something that might be a little bit in your time zone, Stefan, because usually we target the US. This one's targeting the EMEA, so there might be some overlap. So it's going to be a really great event that combines all of the DevOps communities in Tel Aviv, DevOps Days, Cloud Native Days, StatsCraft, which is a monitoring conference, and DevSecOn. So join us on December 17th. There's a registration link on the homepage. And our next session will be with Ronen Levinson, and it's happening December 8th. It'll be live just like this one. So join us. Thank you so much, Stefan, again. It really was a pleasure having you here. And thank you all. Happy holidays, and we will see you at the next one. Thank you so much.
Thanks, everybody. Have a great day ahead. Bye-bye. Thanks, Sharon.